Hello, 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 ladies and gentlemen. Root Beer here, and we're going to finish off our 2012 Pascal Math Contest in this video by looking at question 25. There are four people in a room. For every two people, there is a 50% chance they are friends. Okay. Two people are connected if they are friends, or a third person is friends with both of them, or they have different friends who are friends with each other. Okay. Now, I want to sort of understand the friendship relationship. So what I'm going to do is I'm going to model this sort of situation with a graph. I'm going to let A, B, and C, maybe Alphonse, Beryl, Colleen, and Dennis, be my people. And if they are friends, I'm going to draw a line between them. Okay? Friendship is a relationship that involves two people. So 2 points, well, you need 2 points to be the endpoints of a line. Okay? Now, if I'm understanding connected right, A and B are connected. And this makes sense from a graph perspective because, yeah, there's a line between them. Now, if A is friends with D, B and D might not be friends, but B and D are connected because they've got a mutual person who is a friend. And you can see the connected language is really helping here because D and B are connected. There is sort of a path from D to B. And if maybe B is a friend with C, I would draw this sort of a line. C and D aren't friends, but C is friends with B, D is friends with A, and A and B are friends. So they have different friends who are friends of each other. But I can still very visually see that they are connected because there's a line from D to C. It just passes through some other people. Okay? So this is a great way to visualize what's going on with this relationship. And I don't think it's a coincidence that they use the language connected. I think somebody thought up a graph question and then they made it a grade 9 question. Anyways, what is the probability that every pair of people in the room is connected? Okay. Now, having visualized the problem like this, it's very easy to see if someone isn't connected. Right? I've got my people like this, and maybe these guys are connected. Beryl and Colleen and Dennis, they're all friends. Alphonse isn't friends with anyone here. Right? They're not connected. So what I need is for if every pair of people in the room is connected, everyone's got to be connected. So I need lines connecting everyone to everyone else. Here's another way they might not be connected. Maybe Alphonse and Beryl are friends, Colleen and Dennis are friends, but there's no connection, no way to get from Colleen down here up to Alphonse up here. Okay? So if we start trying to visualize the problem rather than maybe just enumerating cases, it leads us places. Okay? It's really easy to see if someone isn't if they aren't all connected. It's also kind of easy to see if they are all connected. Okay? So what can we do here? Well, we're probably going to need to count. It's a 50% chance that people are friends, 50% chance that they're not. So, well, how many connections are there? Okay. Alphonse has three people he could be friends, so that's a 50% chance to be friends with Dennis, 50% chance Colleen, 50% chance Beryl. Okay? So there's three possible ways for Alphonse to be connected to the rest of the group. Beryl has two ways to be connected to people who they're not already connected to. Colleen only has one way, and Dennis at this point has been connected through previous connections. So I can see that there are 6 possible friendships. So one thing we can do is we could count the number of ways that these friendships connect everyone, okay, form connections through everyone, and then divide by how many connections are possible in total. And so for each friendship, well, it's an equal chance. It's a 1 out of 2 chance that Alphonse and Dennis are friends. So there's 2 possibilities for every friendship, and that means there's going to be 2 to the 6 different possible sort of graphs. And, there's one, or there's one. They wouldn't be connected there. Here's another one. Okay. There's 64 of these, 2 to the 6. because each one could be either a friendship or maybe there isn't a friendship between two people. Okay? Because it's a 50% chance, we don't have to worry about weighting anything or any other weird probability tricks. It is just a grade 9 paper after all. They're not really going out of their way to confuse you. Okay, but there are 64 possible graphs we could have. Now what we can do is we can try and say, all right, which ones are connected? And if that's easy to do, great. If that's not, we might instead ask the reverse question, how many have them not all connected? And that there isn't a way from Alphonse to everyone else. That sort of a thing. Okay, that's another way to do it. It's sort of doing the opposite, and then we would subtract that from 64, and then we would get the number we want. You do that if it's harder to actually count the thing you want, and easier to count the thing you don't want. Okay. Now, if it's going to be connected, this graph, could we ever get away with using just 2 lines? Well, if I use 2 lines, maybe maybe Dennis and Colleen are connected. My other line, either Alphonse and Beryl are connected, but then they're not connected to Colleen and Dennis, or maybe Alphonse is connected to Dennis or Colleen, but Beryl is left out. So I can see that 2 or less friendships give us a graph that is not connected. Okay. What if I have 3? Okay. Well, if you have 3, you could have something like this, which is absolutely connected. But if you have just 3 friendships, you might have something like this. So 3, well, we don't know. Now, suppose I had 4 friendships. Okay? We'll say Alphonse is friends with Beryl. Now, well, if I want somebody connected to Beryl, they could just be connected to Alphonse. Let's try to make it not connected. Okay, well, if we put Dennis there and then Dennis to Beryl, that's 3 of them. Colleen will still be connected to someone. Right? And you can try and work it other ways, connect these two, but you're going to eventually get a cross connection. So 4 friendships or more tells me they must be connected. Okay? Well, that's great. Okay, so if I have 4 friendships or 5 friendships or 6 friendships, what does 6 friendships look like? How many ways could we get 6 friendships between all these people? Well, there's only 6 possible friendships in the first place, so there's only one way for that to happen. How about 5 friendships? I know for a fact it'll be connected, but how many ways can we do 5 friendships? Well, we know that there's only 6 friendships maximum. To get 5 friendships, just remove one of them. And I've got 6 choices for which one to remove. Maybe Alphonse and Beryl aren't friends, but the whole thing's still connected. For 4, how many ways are there to get just 4 friendships? Okay, this one's a little trickier because we could remove 2 of them. So there's 6 choices for the first thing for me to remove. And then that would leave me 5 more choices for the next friendship to remove. And you'll notice it's still connected. Okay? So I removed this one first and then this one. What if I had removed this one first and then chose to remove this? I'd still get the same friendship relations at the end. So I've counted the same thing twice. So we should actually divide by 2. 6 times 5, 6 choices for the first friendship to get rid of, 5 for the next. That's 30 divided by 2. There's 15 ways to have only 4 friendships in this group. Okay, but no matter what 4 friendships we have, we're guaranteed to be connected. So that's 1, 6, 15. So we're looking at 22 ways to have friendships so far out of a total of 64. I don't need to work with 2 or less friendships. Okay? But 3 friendships, well, it's going to be a little trickier. Okay? So how can we fail to be connected with 3 friendships? Or how can we guarantee that we're connected with 3 friendships? You know, something like this, that works. But of course, we could also have the arrow pointing this way, or the arrow pointing this way, or this way. Okay? So when I do this, I'm picking one person and everybody's connected to them. Okay? So there's obviously going to be 4 ways to do that. Okay? So suppose I don't have one person who's friends with everyone. Maybe Alphonse is only friends with 2 people. Right? I still want to be connected, so Colleen would have to be connected to one of the other 2 people, and you get sort of this U shape. Okay? But of course, that's just sort of coincidence. I mean, that's 4 ways. But who said Alphonse had to be friends with Beryl? Maybe Alphonse is friends with Colleen and Dennis, and Beryl is the person who needs to connect. So Beryl could be doing something like that. Okay. So there's 4 more ways. Or Beryl could have been friends with Colleen. We get another 4 ways. So you get this sort of Z shape. And then I suppose we could have another one. It's like this backwards Z. Okay? So there's 4 more ways. And these ways that we're talking about now have 2 people who are friends with 2 people. Okay? Are there other ways to do this? Are there other ways to have 2 people who are friends with 2 people? Because it's important to be able to count this. Okay? So I've had Alphonse and someone he's adjacent to be friends with 2 people. Okay? And as soon as you do that, I suppose we could have something like this. That's everybody's friends with 2 people there. You have a nice little hourglass shape, and that's 2 ways to do it there. Okay? Is there a way to have 3 people who are friends with 2 people? Well, we've got 4 people who are friends with 2 people. What if I had 3 people who are friends with 2 people? You'll notice it's getting a little harder to think through this, and we're breaking one of my cardinal rules when you do counting puzzles is do your best to be organized. And I'm just sort of throwing these together. So it's possible I might be missing something. And you got to watch out for something like that. Maybe they're friends, and now he's friends with 2 people, and maybe they're friends. But that leaves somebody left out, so that's not good. Okay. Now, if we think we have it, 2, 4, 4, 4, 4, so that'd be 18. 18 plus our 22 would be 40. 40 out of 64. You divide by 8 and you get 5 out of 8. You could say, do I have 5 out of 8? I don't see anything that looks like 5 out of 8. You might say, are we missing something, or did we count something extra? And it can be hard to try and work it out. It really can. I firmly believe there's something I've missed here, because we've got these 18 different ways, and then we had 22 from these 40, so should be 5 out of 8, but there isn't a 5 out of 8. I guess this one here is 5 out of 8, so maybe the answer is B. But getting to my larger point, how do we know? How do we know we got it right? Well, what we could do is, oops, we could do this one twice here. And, oh, and I just realized this one here is actually 4, which we already dealt with. I'll get back to my point, the point that I was making in a moment. But having these two have to be friends with 2 people. If they're friends with other people, then that's too many friendships. So they would have to have been friends with each other at some point. So that wasn't actually 1. So we really have 16 plus 22, which should be 38 out of 64. But again, how do we know we're right? Okay, I've just been counting these sort of randomly without a whole lot of thought and organization going through them. Well, one way to do it is to, of course, introduce some organization, but another way to do it would be to maybe count and make sure that the ones that that don't work, that have 3, are all accounted for. So how many would have just 3 friendships? Right? We know there's 6 friendships in total. And we know that gives me 64 different possibilities for drawing this graph. But if I just wanted 3, I could remove 6 choices for a friendship to remove, 5 for the next one to remove, 4 for the next one to remove. Okay? But that first friendship I removed, so, you know, maybe if we label our friendships A, B, C, D, E, F, if I remove friendship F, then B, then C, how is that different than removing friendship C, F, and then B? Okay, the order here doesn't matter, just which friendships have been removed. And there's 6 ways to organize all these friendships. Okay? 3 times 2 times 1. So we know that there are 20 ways that have 3 friendships. Okay? So what we're saying here is I've got 4, 4, 4. I've got 16 different ways to have 3 friendships in the group. There should be 4 more. Can I find those other 4? And are they connected or are they disconnected? We've actually already drawn them. Okay? It's the triangle with someone left out. That's 3. And there's 4 choices for who is left out of the friendship triangle. Okay? So that's the other 4 ways, and those definitely don't work. They are not connected. We double check. These are all different. You know, the N's, Z's, and backwards ones, the buckets, the arrows, and the sort of crosses, I guess you might call them, or flags or something. But that's everything that involves just 3 of them. Okay? So that should be 16 of those, plus the 22 others, gives me 38. So 38 out of the 64 possible friendships. That goes down to 19 out of 32. Can't be reduced any further. Do we see anything that looks like 19 over 32? D. Okay. So a couple takeaways from this one. The visualization is very useful. So making that connection early on is very good. For any probability question, you do need to know how many possible things there are in total, and then you need to count the number of things you want. Okay? And you need to be careful with how you count the things you want. These weren't that bad, but it got a little messy in here. And for a moment there, I actually had something that didn't count, and I almost circled B as my answer. Okay? It just sort of caught me out of the corner of my eye. So you want to be organized, and one way to do that is to make sure you account for the things that don't work. So there's our answer D. Now, you're more than welcome to sort of move on. You know, if you want to take a look at other Pascals, or if you want to try something harder, Kaylee 2012 is certainly good, and I've got other Pascals. But we can approach this another way. I'm going to instead count the number of ways to do the opposite. Okay? Now, when it comes to 3 friendships, we know that there are 4 ways to not have this group be connected. What about 2 ways? So here I'm going to count the opposite. I should get an answer of 13 out of 32. And then I'll subtract that from 32, or I guess 26 out of 64. Okay? So there's 4 ways to not be connected. Now we're doing the opposite problem. What if I had only 2 friendships? I know I won't be connected, but how many ways do you have just 2 friendships? Well, if we imagine sort of these people just meeting, instead of taking away friendships, we could say, well, there's 6 possible choices of the first friendship to add in, and 5 possible choices for the second friendship to add in. But again, it doesn't matter when you add these friendships in, when you create them, when you add the lines in. So, if you do this one, then this one, that's the same as if you did this one and then this one. The order doesn't matter, so we divide by 2. So there's 15 ways to have just 2 friendships, and obviously those won't be connected. What about 1 friendship? Well, there's 6 choices for that. 0 friendships? Well, that would just be the people by themselves. Okay? And so these numbers were a little easier to come by. Although you would be hesitant to say this 4 is it. You would have to stop and think, okay, do I know for a fact that if I don't have these connected up in a triangle, that it would have to be connected? Okay, but if we do that, we get 4, 1, 6, so that's a total of 26. There's 26 ways to not be connected, 64 ways in total. So that's another way to say, oh, there's 38 ways to get a connected friendship graph. That's another approach. You can always count the opposite and subtract it from the total. But I'm fine with the way we did it. Okay. Nice little probability question and a good way to end our Pascal paper. Okay. So thank you guys so much for watching, and I'll see you for more math in the future.